Yeah, good morning, everyone. So, this is also another lesson series on sequences and series. And for this module, we'll continue to look at some examples under geometric progression. And then we will, if we still have time, we'll touch on some of geometric progression or exponential sequence. So, yes, we are still on geometric progression. Yeah. Can you see my screen? All right. Okay, so let's see. So there's also another example. It might look similar to. Okay, thanks for the update, Bennett. It might look similar to that of what we were doing yesterday. If if the second and fourth terms of a geometric progression GP of positive terms are 8 and 32 respectively. Find A, the common ratio, and B, the first thing. Okay. Okay, so this is exactly similar to what we were doing yesterday. So look at this yourself. I'm giving you 2 minutes. So it's now it's now 53. So when it's 55, I'll pause the recording. Okay, so if the second and fourth term of a geometric progression of positive terms are 8 and 32 respectively, find the common ratio. And then the first term. Confirm if you can hear me.
Yes, sir.
Okay, so we are looking at the solution from the student. So first you write a formula. To find the n term of exponential sequences, it's AR exponent n minus 1. Now that said, it says the second and fourth term. So second term will be U2. That'll be AR2 minus 1. Wherever you see and you put 2 there because it says second term. So you have U2 to be AR exponent 1. And they said the second term in the question, the second term is 8. Fourth term is 32. Yeah, second and fourth term is 8 and 32. Respectively means the one you said first, which is second, goes for 8, fourth goes for 32. Yeah, so the fourth term, AR exponent 4 minus 1, that'll be AR exponent 3. But the fourth term is 32. So AR exponent 3 becomes 32. Now, she was solving it simultaneously. And she was doing equation 2 minus equation 1. How? That's wrong. Hello? If you are
Yes, sir.
saying equation 2 minus, that's wrong. Equation 2 minus equation 1. Do you know what it means? Equation 2, equation 2 is AR equals 8. Equation 2 is AR squared equals 32. 32. AR cube also.
So it was supposed to be divided.
Yeah, so what you've done is wrong. If you are saying minus, what it means is AR equation, there's equation 1, there's equation 2. So if you are saying minus is AR exponent 3 minus AR, and per rules of algebra, you can't subtract this. They are not the same. To be able to subtract, the letters must be if here is A, here must be A. If here is R cube, it should be R cube. So you cannot subtract.
Yes, sir.
Now, if you divide in equation 2, so the expression must change to equation 2 divided by equation 1. And anyone in the audience, if you're wondering, that would be AR cube equals 32. This is equation 2. She said divided by equation 1. So that will be over equation 1 is AR. Of course, equal sign is there. Yeah, it's equal to 8. And this one cancels that. One of the R will cancel one of that here. You'll be left with R squared. So R squared will be 32 over 8 is what? I think you know. It's 4.
Yeah.
So if you're wondering how she had R squared equals 4, that's where it's coming from. Then now you take square roots because you want to take the square off. So, and math, whatever you do on the left-hand side, you have to do the same thing on the right-hand side. So since you're taking square root here, you have to take square root at the other side. So R is equal to 2. Then now, you have to put R equals 2 into equation 1. Equation 1 is AR equals 8. So wherever you see R, you put 2 there. So you have 2A equals 8. A is equal to 8 over 2. A is equal to 4. Now, what was the question? So after every solution, you have to conclude. Are you taking note of all these corrections? You don't leave it at this. So you have to conclude that therefore the common ratio is 4, is 2, and the first term is 4. You have to conclude. The solution was incomplete. Okay, let's look at another one. All right, example 2. The third term, Sorry, let's use this one. Uh, the first term in common ratio. The eighth term in the sequence. All right. So try this and let's see. Can you hear me?
Yes, sir.
You have 2 minutes for this. 3 minutes, 1 minute for writing the question, 2 minutes for this. All right, we look at the solution to this very question. So the third and the sixth term of an exponential sequence are 1 over 4 and 1 over 32 respectively. Now we have to find the first term and the common ratio. So let's look at that first. So third term will be 1 over 4, sixth term will be 1 over 32. Let's see what they have here. Third term 1 over 4. All right, so they wrote the expression, they wrote the formula. Now, third term, U3 is equal to AR exponent 3 minus 1. So U3 is equal to AR exponent 2. AR is equal to AR exponent 2 equals 1 over 4 equation 1. That's true. Then, what was that? Third and C term. C term is 1 over 32. U6 is equal to AR exponent 6 minus 1. U6 is equal to AR exponent 5. AR exponent 5 equals 1 over 32. Now, if you had to take equation 2, you did not name the equation. You did not name the equation. What should be the name?
Equation 2.
Okay, so write it on the board. Then equation 2 divided by equation 1. So equation 2 is AR exponent 5 over AR exponent 2, right? Equals, for equation 1 to, is that an equal sign? And then you said equation 2 divided by equation 1. Equation 2 is 1 over 32. Y times. You just jump a step and then continue like that. And you want me to buy this? Do it again and send it to me now.
All right, sir.
I'm not buying the solution.
This one.
All right, there isn't the solution, but I'm only interested in that part. So equation, poor camera quality. Divide equation 2 by equation 1. So you have Oh, this is very bad.
Oh,
The quality is poor.
you
Send it
want to send
again.
it?
I'm waiting.
Right. Who send this ever? Because I'm getting this. I'm sending it. Ever they have the same phrase too. I've sent it to you already. Ah, why did you send it? We need it and say ever first. I mean, send it. I have sent it. Have you received it? No. Oh, yeah. I've sent it. That's always no. Okay. Have you sent it yet?
She claims she sent it.
Yeah.
All right. So, um, divide equation 2 by equation 1. So that's going to be AR5 over AR2 equals 1 over 32 over 1 over 4. AR, oh yeah, right. So that'll be R 5 minus 2. Okay. Because 1 over 32 times 4 over 1. Yeah. Yeah, if it's divided, you reciprocate. Sorry, you introduce multiplication, then you reciprocate. You did this back in junior high school. You have 1 over 32. 1 over 32 divided by 1 over 4. So if you want to solve this, it should be 1 over 32. For division, you introduce multiplication, then you turn the other fraction upside down. That's what she did.
Yes,
Yeah,
sir.
so that'll be um 1 over 8. Now you take cube root of that. Yeah, cube root of r exponent 3. Yeah, equals cube root of 1 over 8. So r is equal to 1 over 2. Now put 1 over 2 into equation 1. AR exponent 2 equals, yeah, equals 1 over 4. Now a into bracket 1 over 2, yeah. You replace that 1 over 2 for the r squared equals 1 over 4. So you have a in bracket, the square one for the fraction, so it will be 1 squared over 2 squared, which is 1 over 2 squared is 4. Yeah, yeah, so now you divide by 1 over 4. You divide by 1 over 4. A is equal to 1. So that is it. Now U8 is equal to AR exponent 8 minus 1, so R7. Okay, okay. 1 over 128. Yeah, right. All right, there is one more question. Hold on. Now there is one more. Okay, question number 3. 3 consecutive terms of a geometric series. Don't just be solving blindly because we are doing geometric progressions. That statement in the question should be appreciated. half product 343, and sum. Sum is 49 over 2. Find the numbers. Yeah, find the numbers. Can you see the question?
Yes.
So with this one, you have about 5 minutes to do that. Be very quick. But before that, Charity, what's going on with her?
She's there. Oh, she's there.
Is she okay?
Yes.
Rhoda, Dennis, Patience, Linda, Andrews, Ryle. I understand Victoria is unwell and has to go home. Is there any other person again?
Yes, like it's Hannah. Hannah.
Okay, all right. Solution. Hannah, you are welcome. Okay, so three consecutive term. Now we have to establish the consecutive term. This one, I want you to do it. Yes, what were your consecutive terms?
Yeah.
Because this, if you don't know, then I'm not continuing. Let the three consecutive consecutive terms. Consecutive. Did I spell it well? No, there should be a C. Let the three consecutive terms be what? Be what?
A.
Yes, see, I'm listening.
A.
Na A no mu gyina me na mtoa so.
A. And AR square.
Yeah, so AR and AR all squared. You guys are brilliant. Yeah, that's all. Because for every GP, the first term is A. To get the second term is AR exponent, n minus 1, and n is 2, so 2 minus 1. AR exponent 1. So that's how come you see AR there. Then U3 will be AR exponent 2 sorry, 3 minus 1. So that'll be AR exponent 2. So that's what you see over there.
Yes.
All right. Are you okay or I'm rushing on it?
No, yeah.
All right. So then now, they said these three consecutive terms have products. What do you understand by product? Of
Multiplication.
course.
Yeah, brilliant.
So A times what? AR times what? AR2. So this product, they said the product is 343. So but let's
Ew.
do it well.
Ew.
Let's do it well. Forget about this and let's deal with this too. If you're
Okay.
multiplying this, it's going to be A squared R what cube, isn't it?
Yes.
Yeah. Remember now A will come because 343. So you have A what cube R what cube equals 343.
Yes.
Which what? One.
No.
No.
Yes. Hey.
Okay. Can I move on?
Yes.
Then sum is what? A plus what? AR plus AR what? Squared. It's equal to sum is 49 over 2. But let's do it well before we can name it. This you
Okay.
cannot add because to in algebra to be able to add the variables must be the same. So
Yeah.
you cannot add. So equation 2. Yeah.
Okay.
All right. Now we are looking at how to solve it. So I'm planning.
Yeah.
Let me see. Should we make change of subject? What do you want us to do? Make A the subject in equation 1. Yeah, make A the subject in equation 1. So A cube R cube will be equal to 343. Making
Yeah.
A the subject will be I'm coming. Yeah. A cube R cube equals 343. Are they following? If you're making A the subject, you divide by what? R cube, right? So that it goes away. And math, whatever you did here, have to do the same thing here. So, so you have A cube to be equal to 343 over R cube. But we said make A the subject, not E cube, right? Right. So you would have to so you people will not mind me or what?
Yes, since we are talking.
Okay. So you take cube root, so that it cancels out.
Yeah.
And math,
Yes.
whatever you do here, you do the same thing here. So that one to cube root. So now A is equal to. Now the cube root affects the top. So it's like cube root of 343. It's also affected down. Cube root of what? R cube. Guys, cube root of 343. Let me turn on my video.
Yes.
Watch me. Yeah. If you want to see cube root, on top of this key, there is a root sign. On top of that root sign, you see cube root there, but it's ash. So to be able to get that feature, press shift. Is it ash or yellow? Whatever the color is. I'm not good with colors. It's good. You press that. You press the shift key, then you press that. You see? So cube root. I have cube root. Did you get that?
Yes.
All right. So that is it. Yeah, cube root of what? 343. Let's see. I'm hoping it gives us a simple number. It did. So it's 7. All over. Cube root of R cube. Cube will cancel cube root. You are left with R. 7 over R. This would be very simple. All right. So now, what's that? I said make A. So put A equals 7 over R into one of the equation. Equation what?
One.
No, no, you don't substitute into the equation you did change of subject from. You understand?
Yes.
So let's do it. No? All right. Just a moment, guys. So it's doing a lot of things. Yeah, so yeah, so it's doing a lot of things, so bear with me. All right. So into equation what? 2, eh? Equation 2, that would be A plus AR plus what? AR2 equals 49 over 2. So that would be 7 over R plus 7 over R. We good?
Yes.
Plus,
Plus
um,
7 of
yeah, 7.
R.
I got lost. I got lost. Sorry. Let me make this decent. Let me make this decent. So it's what? Plus 7 over R times R plus 7 over R times R squared. Oh, come on. You couldn't solve this.
49.
I'm disappointed in you all. Plus, it will
Oh,
cancel. Yeah, left is 7 plus. This one will come and take one of this. You have R 7 times R 7R equals 49 over what? 2. Ah, you have 7 over R. Bring the R here. So plus 7R, right? Move the 7 across the equal sign. So it will go a minus 7. Right? This one, if you are finding the LCM is R, right? R into R, yes,
not
yes. Should I go on?
the no. Say the 49 is over 2, not over 7.
Hmm? Yeah, over two. Thank you.
Yeah.
Yeah, over two. Yeah, but so the LCM is R. R into R is 1. 1 times 7 is 7 plus 1 into R is R. R times 7R is 7R squared equals 49 over 2 minus 7 is what? LCM is 2, right?
Yeah.
Guys, to be honest, I wish you tell me the final answer. Let's put this on the calculator. Because the step is wrong, so no one will come and check that. 49 over 2 minus 7 is what? 35 over 2.
Yes, how?
Yeah. 35 over what? 2. I remember if it was years ago, I'll be solving all that, but trust me, it's not necessary. It's not, it doesn't look like where you're going to be awarded marks. Yeah. If it was years ago, I'll be solving it. Okay. 7 plus 7R cannot be added. So you let's cross multiply. You see?
Okay.
So that'll be 2 times the whole top, right? It will be 2
Yeah.
times. You let me do it for you. 7 plus 7. Because some people will not understand. Because
Yes.
35R.
Yes.
Hmm. So now you have 14 plus 14R squared equals what? 35.
How?
And last time I thought this is a quadratic. The moment you have an equation, you have a squared on the variable as the highest power or degree, it's a quadratic. Quadratics are of the form AS squared, right? Plus what? X
BS
plus
plus.
C equals 0. Quadratic equations, this is how they are. So arrange this to look like that. So 14R squared will come first. The next one will be some, you see, it's X squared. So the next one will be X. The reduction of the squared, right? So
Yes.
we have to bring the 35. So it will be minus 35 what? R. You come to me, okay? Then equal, no, not equals. Wait. Then the next one will be the C, the number
Yeah.
without variable. So it's 14. 14 is positive. So let me make it plus 14. Then equals what? You were
Yeah.
here and you moved it. So it will be 0. We are done.
Yeah.
Then now, yeah, quadratics, we have a special way of solving it. Okay, so go to the calculator.
No.
Go to the
Okay.
calculator.
Yeah, never forget that.
Yeah, so mode 5 3. But before you do, check mode 5 is equation. 5 is equation.
On the right.
Yeah, and then you see quadratic AS squared plus BX plus C. You see it right? Mode 5 3. Yeah. Okay, so now it will ask you A, put 14. You see, A is the coefficient of S squared. So 14, press 14 and press equal to. Then the next one is minus 35. That's the coefficient of R. So minus 35 equal to, then the next one is 14 equal to, right? It will give you all the answers. What are the answers?
X1 is equal to 2. X2 is equal to 1 over 2.
So the answers are 2 and what? 1 over 2. But we have to show working, right? So last time I taught you a secret. When the calculator give you these two answers, you take the variable r, isn't it? Then
Yes.
if the answer was positive to make it -2 here, we have to express it in factors. Here, r is positive, right? So make it -1 over what, 2 equals 0. But this is not it all. When you are smart to think of this, then the next thing you have to do is that I said we don't have fractions, like we don't entertain fraction. So what would you do? Last time I said something. Creating factors, I said something.
You put the 2 as well as the
Louder.
louder. Talk.
We are recording the lecture. Hmm?
Sir, you put the 2 as well as the
Where?
where the 0 is. After the equal to sign.
Here.
Yeah.
Here.
No.
To become 20.
No.
So where?
Why I was saying now the selection. Who should stop that? But I don't know, she is those two. When demons, or tapi na beda.
Hmm. I said this the other time. He never went home to read. All right. This brings us to the end of the session. If you figure it
Oh,
out, we'll continue some other time.
okay. Okay.